my son Logan, and he is a pretty spectacular grade 6 mathematician. Can you say hi, Logan?
Hello.
So for this math learning log, what we're going to be doing is putting fractions on a number line. So Mommy struggles a little bit with this, so I was hoping by talking it out with you, I could accomplish two things. I could learn something from you, and maybe you learn something from me, and also I could demonstrate how to facilitate math talk in a junior classroom. Okay?
Okay.
So we have here our number line. And up in our cloud here, we have some improper fractions, we have some decimals, we have some percentages. So all of which you've done before.
Yeah.
Yes. Okay. And looking at our number line, can you tell me something about the number line? Anything about the number line? Have you used a number line before?
Yes, I've used the number line organizing numbers.
Okay.
And there's a 0 always at the beginning.
Okay. So there's a 0 at the beginning. Great. So that's a great start. So is there anything else you notice about the number line here that Mommy's made?
Marks. Right?
Marks. Okay. What about those marks? Why would Mommy just randomly put those marks there, do you think?
Maybe so. 1, 2, 3. To represent a whole.
To represent a whole? Great. So why don't you go ahead and mark the 0 on the number line, and then we'll take a look at where the rest of the markings what the rest of the markings might be. So you said you counted these. I saw you counted them. Why did you do that? What does that mean to you?
Usually 10%. Like usually one of these usually equal like a 10.
A tenth, okay.
And 10 tenths equal a whole.
10 tenths equal whole, okay. So saying that, what would we put here for this notch?
1 whole.
1 whole, good, okay. So 1 whole, great. So we're going to go ahead and put the 1 there.
And this one would be a 2 then.
Okay.
And this would be a 3.
Yes, okay, great. Okay, so we've constructed our number line. We know that each of them has 10 tenths to make a whole. So we have 1, 2, 3 wholes. And now I guess we can start taking our numbers from our fraction cloud, or our cloud up here, and put them on the horizon on our number line. So starting with the third one, starting with the first one, 6/3. Tell me what you know about that.
Well, I know that 3 is on the...
You can talk to the camera.
Oh, so I know that there's 3 plus 3 equals 6. So
Okay.
I know that is 2 wholes.
2 wholes, great.
So I think I'm going to mark this one number 1. I'm going to add number 1.
Or we can just actually mark the 6/3 up above to keep us straight, yeah. Great. It's okay. And let's just cross that one off because we've taken it out of the cloud and put it on our number line. Great, okay.
Yeah.
What can you tell me about this one? What does that even mean, those numbers?
If there's a 0, it doesn't have a whole.
Okay.
And it's 70%, and one of these equals 10%. So it's going to have 7 of these.
So am I hearing you say that 0.7 actually equals
70%.
70%, okay. And you said that it fits here on our number line because
there's not a 1.
Okay, because you said that's 7 tenths, correct? So 70% equals 7 tenths?
Yeah.
Yeah, great. That's really great. Okay, so let's go ahead and mark our 7 tenths there then.
I'm just going to write it. Can I draw like a line?
Go ahead.
7.
10. Or 70. You can just use these numbers too, right? Yeah, good. Okay, great. Okay, so we can cross that one out of the cloud too. Okay, now let's look at the next one, 7/5. That one might be a little more trickier. I know Mummy found that one really tricky when I was doing this question. So tell me what you know about 7/5. What can we work with there?
Well, I know that there's already one whole because there is 7, and if you 5 add 7, there's 2 more. So I already know there's going to be one whole. But we need to make that. Into these. So you need to double it up to make it 10%.
Okay.
And then you need to double up the 4 to make 14. So I think it goes.
So you're saying that this would represent 14 tenths?
1 14/10.
Okay, so 14 tenths, okay? All right. Because if you've taken the 5 and multiplied it by 2 to get 10, then you have to take the 7 and multiply it by 2. How do you know to do that? Do you just know to automatically do that? That if I did something to this number,
you have to if you do to the bottom number, the thing that you do to the bottom number, you have to do to the top number. My teacher told me that.
Oh, your teacher did. Good. Okay. Great. So that's correct. Whatever you do to the denominator, you have to do to the numerator and vice versa. Good. Okay. It's just kind of a math rule, isn't it?
Yeah.
Yeah. Okay. So if we do that, we end up with 14 tenths. Where can I put 14 tenths on this number line? Where would I be able to fit that in?
About right here, because in the middle is going to be 15, so just a little bit notched back.
Okay.
14.
So let's look at that. 14 tenths. Let's write 14 tenths here.
Or you could round it to 15.
Okay, well let's start by writing 14 tenths here. Let's work through this. Okay, so tenth, and we have 14. So let's relate it to pizza maybe. Okay?
Yeah.
So if I have a pizza and I cut it and my pizza is 10 slices.
Yes.
And I know that I'm having 14 friends over to my party. 14 friends, one pizza with 10 slices. Do I have enough pizza to feed all my friends?
You need to add.
Okay. But what do I have?
10 slices.
10 slices? How many more do I need?
4 more slices of pizza to
4
feed
more
all the
slices
friends.
of pizza, right. So I know that my one pepperoni pizza equals 10 slices, right?
Yeah.
Pardon Mommy's writing. It's not very neat with my right hand. And you said how many pieces we needed left over?
We needed 4 more, not left
4
over.
more. Oh, yes, not left over. That's right. We needed 4 more. We don't have any left over, do we? We need 4 more from another pizza. So, 10 slices, 4 more. What if I cut this pizza into tenths?
You have 6 remaining.
Okay, great. But how many would I take from that tenth?
4.
4, right. So then, saying that, we have 1 whole pizza,
Okay.
and we need 4 tenths left over.
So it'd be 140, because it's
Right. So let's go ahead and mark that on there. Right.
the 1.
So there's my 1 whole pizza, and then that would equal my 7/5.
That one was tricky.
It was very tricky.
Mark that off.
And this one might even be trickier, the 9/4. What do we know about 9/4?
Well, 4 plus 4 is 8, which would
Okay.
make it into 2 wholes. So you know that right off the bat it's going to be more than 2.
Okay.
And
How much do we have left?
1/10. 1/10.
1/10? Is this a tenth though?
No. Yeah.
Nope, not
For sure.
So you said if we take the 8th would equal 2 because 8 over 4 is 2 wholes, right? So 2 equals 8/4. But we have how much? 9/4.
9/4.
Yeah.
So it would be extra 1 on top. So maybe it would be here.
Okay, so in that left, what number should I put here? The 8/4 equals our 2. And we have how much with 9/4 left over?
9/4, 1.
1. So we have 1/4 left over.
So we have a quarter.
I was just going to ask you that. What do we know about 1/4? Yeah.
Well, if you take 1/4, it would be a quarter, because.
Good. So where would we put that on our number line then? 2
between
and 1/4.
20 and 30, like
Awesome.
between there.
Good. And Logan, how do you know that?
Because if 20 and half in between 20, look at a clock, for example. There's 5, 10, 15, 20, then 25, 30. So in between those two would be a 25. So
Okay.
if you mark
Interesting.
in between, that would be the 9.
So is it fair to say then that you would break quarters up by thinking of a clock?
Yeah,
Yeah. Interesting.
Well, kind of a split.
Can you
half.
tell me about that strategy, a little bit more about it?
Well, if I'm doing like some, because I know there's 25 and 50 in a clock, so if I'm working under a half, I use that strategy.
Okay. How so? How do you use that strategy?
So like,
Can you draw it out for me too? If you, yeah. But let's just make sure. Oh, yeah, Kate can see it
I
great.
flip the clock into half.
Okay.
So here doesn't matter.
Okay.
What kind of does? 'Cause
Nice and loud.
I made a mistake. I'm drawing new one.
Okay. No problem.
Just forget about this one.
That's okay.
I'm gonna make a big one right here. So if you go 5, 10, 15, 20, 25, 30.
Okay.
25 is right here.
Okay.
30, 35, 40, 45, 50. I can't draw so. Is in between there, so this stuff doesn't really matter. So say that like, if you're talking about, you're taking it's hard to explain. It's just something that I
Okay.
use.
How about I draw you a clock here? Well, we're kind of running out of room here, but that's okay.
Up there.
We'll draw it up here. And you're saying the clock's like this. So this
Yeah.
would be like 12 o'clock.
Yeah.
And this would be like a 6. And this would be 3 for the 15. And this would be 9.
Yeah.
So how is it that you relate fractions to that clock?
So 12 is 60.
Okay.
9 is, well, they're 15 each round. So
15.
45,
Okay.
30, 15, then it goes back to 0. So if there's like 25, and like if I'm using it like, because there's like 4 fractions in a clock,
Okay.
but each of them equal 15. But 15 plus 15 equals 30.
Okay.
Minus 5 would be 1 under, which would be 25.
Okay.
Which I take, and I like.
Yeah, and again, for you to explain this strategy to me, I'm just curious how you use the clock to figure out fractions. Because I
use
know
the
a couple
clock mostly
times,
for everything.
I know a couple times when we've been doing homework, you really nailed the questions, and you always tell me, I just think about a clock. So I'm really curious to know. We're doing fractions right now, so relating the clock to fractions, like how do you use that benchmark or that image to relate to fractions? That's what I was curious. So not specifically to the question we're figuring out right now, but just in general. How do you use the clock? It's
Well, say that's like a fraction. 1 over 4, which is exactly there.
yeah, nice and loud because Kate needs to hear you. Okay.
So 1 over 4 is right there. Anyway, so I know that 1/4 is 25.
Mhm.
And if you kind of look like a clock, it's kind of like a round number line.
Sort of, isn't it?
It's like a number line that
Yeah.
goes around, but like instead of 10, every 10 it's 5, 5, 5,
That's
5,
interesting.
5, 5.
I never thought of it
So
that
that's
way.
how I figure it out.
And those are kind of benchmark numbers, aren't they? Your 5s and 10s.
5s, 10s, 15s, 20s, and so on.
Yeah.
It's just found it every
So do you relate a lot of math thinking to like a clock, say?
loads.
Loads of it? Okay, interesting.
I'll do all my multiplications with a clock.
How do you do multiplications with a clock?
Another time.
No, show me how you do it.
Okay, so like, say that's 4 times 15. I know that 15 plus 15 equals 30. 30 plus 30 equals 60. Because I just looked, because 15 equals 30 on a clock. 6 plus 6 equals 12. 12 on a clock is 60. It goes right back
Neat.
to the answer.
Is that a strategy that you were taught, or did you come up with that on your own?
Came up with that on my own.
Yeah? So you multiplication, it really helps you figure it out.
Mhm.
Really, that's really cool. I really like that. It's a neat strategy. Maybe Mommy and you need to talk some more about that before Mommy's math exam. Okay, so just so we're not hours later, let's look at the 1.6. Where would you put the 1.6 on our clock? And what does 1.6 even mean?
You can't do decimals on the clock.
Oh, no, I'm sorry. Did I say clock? I meant our number
Yeah.
line. Where would you put... Yeah, you can't really do decimals
Yeah.
on your clock.
Okay. Hard.
Where would you put the 1.6 on our fraction number line?
Well, 1.6 is equivalent to 1 whole and 6 tenths.
Good.
So
Okay. So 1 whole and 6 tenths. Really
so
cool.
just
That's great.
right there.
Great math talk, too. I like how you're using your tenths. And our very last one,
25%. Which
easy peasy lemon squeezy.
because we just did it.
Yeah. So
So-
where would we put that?
Right here. 25%.
Awesome job. So we've taken all our fractions out of our cloud. We've got them all in our number line. We've learned a new strategy using the clock for multiplication, which
Yeah.
we're going to talk some more about, and on our own. And also, do you have any advice for Mommy in the math classroom?
Clock.
Think about a clock.
No, just look at the clock in the classroom.
Okay, any other good advice for when Mommy's teaching kids your age?
No.
So if you had a dream math teacher, what would she be like?
Not give us hard questions.
Not give us hard questions? Good.
Give us just right questions.
Yeah.
At our
Is it
level.
important to you that the questions kind of relate to real life for you?
Well, I like hands-on questions.
Hands-on questions?
Like you do like math, but like with study and stuff. I don't like worksheets.
No worksheets. That's good advice.
Well, worksheets for tests, of course.
Yes.
But like not like go textbooks. Not like
Yeah.
worksheet. Our teacher does textbook too.
Yeah. And do you like it when Mommy makes you think about stuff when we're doing our math homework and that?
Yeah.
Yeah. Why is that helpful, Logan?
Because it's kind of like a, so like do this question, you break it down for me and it gets easier
Yeah.
and easier.
Or you break it down yourself.
Yeah,
don't you?
but you help me break
Yeah,
it down.
and you figure it out, right?
Yeah.
Awesome. Good job. High five. Awesome job on the number line.
Thank you.
I hope you enjoy our video.
Yeah.
And have a great day.